Recorded. Okay, it is being recorded. Okay. Hi, everybody. This thing's on. So what we're talking about in class today is what is called a positive feedback loop. And one of the positive feedback loops that we're talking about today is called the ice albedo feedback loop. So in order to demonstrate how quickly melting ice can actually trigger warming, what I thought I would do is step back out of my apartment. So I'm outside of my apartment again. And just like the last time I showed the white sheet versus the black sheet, well, the white sheet is back. And so I have it sitting on my porch, just outside of my apartment. And let's see what the temperature of it is right now. Okay, so low 70s, 71. Just for the heck of it, let's take a look and see what the temperature of the ground around it is. Dang, 105. So as you can see, there's a big difference in temperature between our sheet covered ground and the exposed ground. Well, this sheet behaves a lot like ice. It's very, very reflective of sunlight. Well, what happens is, as the earth warms up, this ice begins to melt. And as it melts, it gets smaller and smaller and smaller. So I'm going to fold it. And then let me look at the temperature of that area that was just exposed, or that was just shaded from the sun. And let's see what happens to the temperature over the next minute or two. So this was the part of the land that had just been covered by the ice. And now the ice melted. And so I'm over that little area now. And let's wait a minute and see what happens to the temperature. You'd notice it's starting to steadily increase. It's not as warm yet as that 105 degrees that we saw with the land around the sheet. But if you notice, it's beginning to steadily increase. It was, what, 67, 66, 67 when I first started shooting this video. It's now 71. Let's wait a few more minutes to see what happens. So 71. Now here's the thing. The temperature of that ice was freezing. And what happens is, as it melts, because the air around it has gotten warmer, what that's going to do is that's going to cause the air right next to that ice to heat up, because the land right next to that melted ice is going to heat up. What that's going to do is that's going to cause our sheet of ice to actually shrink even more. And the land next to the ice is going to continue heating up. And if you notice over our little area where the ice previously was, the temperature just keeps going up. We're seeing now low to mid 70s, 73. If I were to stay out here for a few more minutes, I'd see 74, 75, 76. So the point is that as temperatures rise, ice begins to melt. Now, as ice begins to melt, the ground beneath the ice, as soon as it becomes exposed, it begins to warm up pretty quickly. I mean, I was out here for just a couple of minutes, and the temperature of that ground already went up 5 or 6 degrees. Now, if I were to hang out here for an hour, very soon, I would see temperatures like that. Very, very warm. And so as our ice is melting, that's making the ground beneath it a lot hotter. As a result, the air above that ground is going to become a lot hotter. And as the air becomes a lot hotter, that's going to cause more ice to melt, leading to more heating, leading to more ice melting, leading to more heating. What kind of a feedback loop do you think that is? All right, so I'm going to turn this off now and
turn it back over to Terrence in the office.